So in this video, I'm going to be discussing chapter 1 of our lecture videos. And this deals with, so there are two sections that I'm going to be talking about, and it'll probably be in two separate videos because of the length of time it would take me to record the two sections. So anyway, sections 1 and 2 is talking about chemistry, chemicals, and the scientific method. All right, chemistry is defined as the study of matter. All right. So for me, of course, the definition of chemistry is just pure fun. All right. But again, if you take the regular definition of chemistry, which is the study of matter. So what is matter? All right, so we'll have to define what matter is. Okay, so matter is, like you can see here in the picture, okay, matter is anything that has mass. You can mass this tablet on a balance, and then you can see that it occupies a finite space. So does the water in the glass, and so does the glass itself. So, and then of course, air surrounding this, all right. We may not be tangibly able to see the air, however, we definitely can feel it, all right, the air pressure on our body. So, matter can be living or non-living matters, and basically we're looking at the fact that it's stuff, and stuff is made up of mass and occupies a certain volume, a space. Okay. The composition of matter is what we then study at, and the composition, of course, matter is made up of atoms and molecules, and therefore we are basically looking at the study of these atoms and molecules that make up matter, and the properties of these matter, whether it's physical, like the state, this is solid, and the water is liquid, or the interactions. For example, as you drop the antacid tablet, you can see that the antacid is reacting with the water by the fizzing that develops, showing some gases is being evolved. All right. So all of this is the study of matter, comprises chemistry. All right. So matter can be anything around us, whether it's food that we consume, which is matter. A tablet is matter. Water is matter. The glass is also matter. The air, surrounding air is matter. The table that you use, the pen, the laptop, your cell phone, you are matter. So matter is anything that is got mass and volume. So there's a particle nature to matter, all right? And those particles are atoms and molecules. Chemicals can be defined as anything that could be of everyday use. So it doesn't have to have a negative connotation. It doesn't have to be something toxic, all right? It can be something that we're using every day. Water is a chemical. So also you're a chemical as well. There are lots of chemicals in your body, all right? In fact, the body is like a pharmacy of chemicals that you can't even find in real life. And so here in this picture, they're showing different brands of toothpaste, all right? And toothpaste is a chemical, even though we may not associate the word chemical with toothpaste, okay? Some of the chemicals that are found in toothpaste are calcium carbonate, and the common name is limestone. And of course, you associate limestone as was limestone formation found in caves, etc. but this is a commonly occurring chemical, calcium carbonate. It's found in antacid. Um, and calcium carbonate has an abrasive quality to it, so it can remove plaque. Sorbitol is a sugar and a sugar alcohol, and it's able to keep the toothpaste from hardening up, so it retains the moisture in the toothpaste and keeps it soft. And sodium lauryl sulfate will loosen up that plaque, and then the calcium carbonate is able to remove it. Titanium dioxide is what makes the toothpaste white and thick, opaque to light. Triclosan is inhibiting growth of bacteria and therefore preserving shelf life of the toothpaste. Sodium fluorophosphate provides fluorides that is necessary to prevent cavity formation and to strengthen the enamel of the tooth. And then methyl salicylate is a form of compound called as esters. Esters have smells and flavors that are associated either with fruit or, in this case, the wintergreen pepperminty type of flavor. Okay. So these are all these chemicals found in just a toothpaste. Again, not many of us will read the labels in packaging, but if you do, it lists every single ingredient, which are all chemicals. Okay. So chemicals are found, like I said, in the things that you don't think of as chemicals. So whether it's the silicon dioxide making up this glass, or the water from the faucet, the fruit, and a lot of the fruit sometimes have that waxiness to it, which is they are adding a chemical there to keep it the fruit, to preserve the fruit. All right. um, and then you have your countertops, which are chemicals as well. The burners um, are again chemicals. The refrigerator is made up of alloys, which is a mixture of metals, and so on. So pretty much everything here in the kitchen that you can visibly see is a chemical. And of course, there's air, which you cannot see visibly, but that's a chemical as well. So, which of the following contains chemicals? And so, remember, chemicals is basically you're looking at matter. So, matter is something that has a particle nature to it, right? So, among the choices, sunlight is energy, there's no particle nature to it, therefore, it's not a chemical. So, what are the different subheadings or the steps to the scientific method? Scientific method is a way to um, study the phenomena around you. So you look at something, you make an observation, you ask a question about why that is happening, all right? And then you go about proposing a reason, an explanation to why, as to why you think that is happening. And then you design some experiments to prove your hypothesis. And once you perform your experiments, you gather data, and then you draw some analysis, some conclusions from that data, and see whether your proposed hypothesis has been proven. If it hasn't, then you have to go back, revise the hypothesis, and then perform a new set of experiments. And hopefully that second hypothesis would be validated. All right. An example would be, again, the story might be myth, but Isaac Newton observed a ripe apple falling to the ground. So he observed that ripened apples are falling to the ground, and he asked the question about why that is so. Why are the ripe apples falling to the ground? Is there a force that is pulling them to the ground? So he hypothesized that there was such a force, and he called it gravity. Then he had to go about, of course, conducting experiments, gathering data and facts to prove his hypothesis. Now, once his results did confirm his hypothesis, then he concluded that this is gravity is real, and then published his results, and then others were able to confirm it. All right, so then it gets in the public domain where other people can also examine and conduct exactly similar experiments. And then, of course, it leads to a theory. Once that theory stands the test of time, it leads to law. And so we now have the law of gravity. Okay. All right, so the scientific method can be applied to anything. It can be applied to something as like baking cookies, or here in this example, it's being applied to why you might be suffering an allergic reaction every time you visit your friend who's got a new cat. And so the hypothesis that you would draw from this is that you're allergic to cats, their hair and dander. But then you'll have to make sure that your hypothesis is correct, so as not to jump to conclusions. So therefore, you would conduct a series of experiments by visiting other people with cats. And then if you do develop an allergic reaction on your visits, then you know for sure that you are allergic to cats. If on the other hand you did not develop the same allergic reaction in those with those other cats, then you'll have to come up with another hypothesis as to what could be that reason, and then set about experiments to prove your second hypothesis. All right, so then once you've gathered your data and you can conclusively prove your hypothesis is correct, you could other times look for other things from your the set of experiment. All right, so sometimes what happens is when you conduct one set of experiments and you've proved one hypothesis, you would get inspired to observe a pattern and then conduct more experiments and prove again the newer hypothesis that you have designed from your new set of experiments, and so on. All right, so it can lead into different directions once you have concluded your first set of experiments. All right, and again, as I said, if the data that you've gathered is able to be reproduced, and it leads to reproducible results by others who test your data, then of course it can over time develop into a theory. All right, and the theory can eventually lead to a law. All right, such as I explained with gravity. Okay. All right, so the subheadings in the scientific method are: you're starting out with asking questions, your observations. It leads to formulating a hypothesis. Then you're conducting experiments and gathering data to confirm your hypothesis. And in your conclusions, you will conclude whether the results of your data are supporting your hypothesis or they're not supporting. If they're not, then you have to work out a different hypothesis and then another fresh new set of experiments to prove the revised hypothesis. Okay. All right, so I will stop here and continue this in the next video.